In this lesson, we're going to continue to look at SOHCAHTOA, or trigonometry. We're going to start developing some ideas about word problems and applications of things. In general, this means we're going to decide on the picture ourselves and then do the math that goes along with it. Trigonometry is one of those really useful real-world applications. You can use this all the time in the real world, in particular for measuring things that are otherwise inaccessible. How tall something is. If I know the angle, I know how far away from something, I can figure out how tall it is. There are two common situations that we're going to come across. They both involve angles. And the words is what's the important part here. Angles of elevation. So again, as I was saying, if I want to know how tall a wall is, and I walk away from it and then look up at the top, it's right angled. The angle of elevation is how high I have to look up. So if I'm standing normally, we say we're looking at the horizontal, straight across. That's an angle of 0. As soon as I start looking up from there, my angle of elevation is increasing. But it's always from the horizontal. In a similar fashion, if I were, let's say, standing on top of a bridge and looking down at something, so now I'm looking down at something, I have an angle of depression. But again, it's from the horizontal. That's the key thing right there, okay? Horizontal and horizontal. So sometimes you're going to have diagrams that don't have horizontal lines in them, and it's useful to draw that line in. Like an imaginary dashed line right down the middle to say, okay, here's 0, here's my angle from 0. These two angles are actually related to each other. If you were, let's say, looking out the window, you're looking up to somebody standing on the roof of something, you'd be looking up. That would be your angle of elevation. But if they were on the roof and they were looking down at you, that would be your angle of depression. So you actually have two angles that sound different, different words, but have the same measurement. They're just from different perspectives. And we use the idea of the Z pattern to say, hey, these two things, based on horizontal lines, have to be equal to each other. So let's start with our basic question. The angle of elevation of the sun is 23 degrees. If the building is 76 meters tall, how long will its shadow be? So if we had the sun and it was shining on this building, it would create a shadow over here. In other words, a right triangle. Okay? For our purposes, we always assume buildings and people and trees are straight up and down, forming right angles. The angle of elevation is 23. So if we were staying on the ground and we looked at the building, that would be 0. But if we looked up at the sun, our angle is 23 degrees. The building is 76 meters tall. How long is its shadow? The shadow is the part that appears on the ground. Well, this is now a SOHCAHTOA question. It's helpful to write that word down to remind ourselves of our three ratios. If I label my triangle according to my angle, I have the opposite. I have the adjacent. O and A is tan. So the tan of our angle, which was 23, equals my opposite, 76, over the adjacent. That's x. That's one of my three basic problems. And when x is in the fraction, we're going to cross multiply. So 1 times 76, x times tan 23. 76. I want to get x by itself, so I need to take 76 and divide it by tan 23. And if I do that using our calculators, we should get approximately 179. Because this is a word problem, we're going to start putting therefore statements in. The shadow is 179 meters long. So today's key is not about learning the math again. We know the three ways of using the math. Today's about drawing the picture and interpreting the situation. Okay, try the next one. A hill rises 50 meters for every 1,000 meters of run. What is the slope angle or the inclination of the hill? So if we think of these people going up the hill right here, going up the hill, and we can turn that into a right triangle. And we know that rise and run in grade 9, okay, rise is your up and down, and run is your left and right. We'll talk about slope in grade 9. That my 1,000 meters of run goes on the horizontal, my 50 meters of rise goes on the vertical. And my slope angle, or inclination, would be how much I have to go up. Go back to SOHCAHTOA. If I label my sides, I have the opposite. I have the adjacent. Tells me to use tan again. Okay, so the tan of our angle is opposite over adjacent. And just to point out to you, you're going to use tan for most things when you talk about word problems, because these are things you can measure. The horizontal, the vertical. Kind of hard to measure diagonals usually. All right, this is another problem. So we had 3 problems. X on the top, X on the bottom, X is the angle. That's this one. Situation number 3. To find angles, we have to use inverses. So tan -1, second function, of whatever 50 divided by 1,000 happens to be. And using your calculator, make sure you use your second function. You should get 2.86. So the hill has a slope angle of 2.86 degrees. Okay, let's try another one. A plane is approaching a runway at an elevation of 2,500 feet. The plane is descending at an angle of 13 degrees. How far is the plane horizontally from the airport? So here's our plane. It's trying to land on the runway over here. Here's our runway. Okay, but right now, the plane is forming this right triangle. We know the plane is at an elevation of 2,500 feet. We know it's descending at an angle of 13. Here's the tricky part. I need you to think about the idea of elevation depression. If the plane kept flying straight, it would form this line, right? That's where the plane would go. But it's not. It's now going down to this line. So my angle of depression is 13 degrees out there, which isn't really in my triangle. But if I use the idea of a Z pattern, I can put it into my triangle by putting it down here. And that's a really big idea. Horizontal is 0. If it kept on going straight, the difference between that is your angle of depression. We want to know how far is this plane horizontally from the airport. Okay, let's do our labeling. This is my opposite. This is my adjacent. That looks like a tan question one more time. So I have the tan of 13 equals opposite over adjacent. Well, we've done a question like this already today. It's like the first one. So we cross multiply 1 times 2,500 and x times the tan of 13. I'll get x by itself. So just divide out tan 13. Now if I use my calculator, I get an answer of 10,828 approximately. Got some decimals there too, 69. Okay, therefore the plane is approximately 10,828.69 feet from the runway. Okay. The math of this, and the math is, I'm hoping, getting a little bit easier. Every time we do this, it gets a little bit easier. The trick here is this angle. It's really common for people to put it right here. And we almost never have that angle. Maybe the top of the triangle. We have the one in the bottom of the triangle. Usually because of the Z pattern. Okay, let's try a little trickier one. The tip of a fishing rod is 1 meter above the water. The fish finder has identified fish at a depth of 45 meters. How much line is needed to catch the fish? The line is at an angle of 67 to the surface. So I put some clip art here just to help us, with the water. So we got our fishing rod. Its tip, 1 meter above the surface. The fish finder has identified fish way down here, 45 meters. Not to scale, okay, but let's say they're down here. Here's my fish. And they're 45 meters below the surface. In other words, they're way down here, 45 meters. To catch those fish, we got to put out some line. Now the line's not going straight down, it's going at an angle of 67 to the surface. So if you will, let's call that down there, trying to catch those fish. 67 to the surface. So that means the angle right here is 67 degrees. And I want to know how much line is needed. So I need to know from here at the top all the way down to here at the bottom, how much line is that? So what can we do? Well, first of all, I hope you would agree that we have two triangles here. We have a small one above the surface, and we have the big one that goes all the way down to the fish. I kind of want to use the big one because that's where my line's going. In the big triangle, we know this distance from top to bottom is 46 meters. It's the 1 meter above the surface and the 45 meters below combined. We also know that the angle of the line mixed with the surface is 67. Now here's your tricky idea. That means this bottom corner also has to be 67. And the reason why is we have the letter F. Okay. We know in F patterns the angles under the arms are equal. And it's the letter F because these two triangles are similar. They have the same angles. Okay. So based on that, I'm going to redraw this diagram just to the side so you can see what I'm using here. We have a right triangle that has a vertical of 46. I want to find how much line I have coming out, and I know the corner is 67 degrees. So if I label that triangle, this is the opposite, and the hypotenuse, that's a sine question. So the sine of our angle equals the opposite over the hypotenuse. We solve these by cross multiplying. 1 times 46 is 46. X times sine 67, x sine 67. I want to get x by itself, so I divide out the sine 67. I'm going to put that all into my calculator. Hopefully we get an answer kind of like 50. So therefore, to catch these fish, we will need 50 meters of line. Yes, that's one of those situations where we don't actually use the sine law. I'm sorry, we don't use tan, we actually use sine because it's something we could measure, a horizontal line, or we want to measure. As I said, most of the times when you do word problems, you're going to come across tan. Don't rely on that. Okay, we're going to skip that last example there. We're going to try some homework questions. Okay, so page 412, 1 to 10 and 16, most of these you have to draw the picture. The picture is going to be the hard part for you guys doing the math. The math it's one of those 3 problems. It's repetitive. But drawing the picture and interpreting the situation is often the tricky part. So give these a try. If you're stuck, come see me, and then we'll go from there.